This conference will now be recorded.
Thank you. Thank you. So our research actually was developed from the work that we are doing with the different stakeholders in fecal sludge management. And although there is a lot of economic activity that happen here in this sector, it is still a very unrecognized sector. And so there is a lack of investment to ensure that there is proper technology maturation and commercialization happening in this sector to grow it. So my co-author Abid will take us through the work in more details to actually show you how the proper investment and planning in the fecal sludge business can provide financial benefits to investors and stakeholders through the production, manufacturing, and service delivery, but also ensure high return on investment. The topic of our session is locally fabricated technology to contemplate circular economy in fecal sludge management, a case study of technology maturation and its impact for Bangladesh. Abid, over to you.
Thanks to my co-author Sonia. So ladies and gentlemen, as you can see, our topic is locally fabricated technology to contemplate circular economy in fecal sludge management, a case study of technology maturation and its impact for Bangladesh. So let us run through the background of our paper. At first, as you can see, our paper attempts to contribute to the goal 6 of Sustainable Development Goals, which indicates clean water and sanitation. And the second point is open defecation. As you know, in previous years, open defecation was one of the major issues in Bangladesh, but by 2017, open defecation rate is almost 0% here. But with the solution to this problem, a new problem has arisen, and that is fecal sludge management, or FSM. If we look at the FSM supply chain, we can see, if you can see this picture, there are 5 different parts. First one is the capture or containment, and the second part is storage, where the fecal sludge is stored, and we have to empty the storage time by time. And the third part is transport, where these from the storage, the fecal sludge have to be taken to the treatment facilities, which is the fourth part. And there in the treatment plants, the fecal sludge should be treated, and then these fecal sludge can be reused, which is the final part of this FSM supply chain. And we have attempted to introduce innovation in this FSM supply chain. And what our innovation is? Our innovation is local fabrication of emptying device and transportation vehicles. And what are the objectives of this paper? At first, it states that locally fabricated equipment and vehicles are contextually best fit. That means what we are intending, that these local fabricated equipment and vehicles will be socially, socio-economically, and infrastructurally the best fit or the perfect fit of our country, especially for the peri-urban and rural area of our country. Another point is these locally fabricated equipment and vehicles are socially most accepted, especially by the sanitation workers who directly work with these devices, and by the beneficiaries, municipal level officials, and the development workers. These local fabrications are obviously cost effective, as we are fabricating these local vehicles and equipment by using our local resources. These are very easy to maintain. Our local technician and mechanic can do the maintenance job very easily. And finally, these local fabrications create more local employment. So what was our methodology of this paper? In the methodology part, to develop this paper, we have followed the qualitative approach, and our main data collection tools were focus group discussion, where the representative from the sanitation workers cooperatives, then municipal officials, both international and national level development workers, donors, and municipal authorities have taken part. Second method was observation. In this part, we have observed the technological procedures of fecal sludge management sector. In the in-depth interview, our representatives from the cooperatives of sanitation workers, municipal officials who closely work with this FSM sector, and the development organizations who work in the wash sector, their representatives have participated in the in-depth interview part. And the key informant interview part the mayor of one of the municipalities in Bangladesh, high-level officials from donor agencies and national and international NGOs and development organizations, and representatives from the sanitation workers cooperatives have taken part. And our target population were the municipality officials, development workers from both national and international organizations and donor organizations, and sweepers and emptiers who use these locally fabricated vehicles and devices. They were the main target population of our paper, and the sampling method which we followed was snowball sampling. And our theoretical framework looks like this. Our basic hypothesis was, as you can see in the left part of the screen, locally fabricated technology strengthens the viability of the FSM service and contributes better to ensure circular economy. And if you look at this circle, this first circle indicates that local technologies ensure better service. It means if we use these local technologies instead of manual facilities or manual system, then more fecal sludge can be treated and a better service can be ensured. And by this, more fecal sludge can be treated. And when fecal sludge can be treated, this waste can turn into acid. And when this waste can be turned into acid, it ensures the dignity of the sanitation worker, because in the past it was perceived like the sanitation worker works with waste. But when they can establish that no, we don't work with waste, rather we can turn this waste into acid, then their work dignity can be increased, and by this their income can also be increased. And when their income is increased, then their lifestyle is changed, lifestyle gets developed or better, and it creates more demand for better technologies which contemplate the local technologies which ensure better service. So it was the basic theoretical framework of our paper. And let us look at the findings and analysis of our paper. So at first we will discuss about the contribution towards circular economy, which indicates how this treated fecal sludge can contemplate circular economy. As you can see, the first point indicates commercial flower cultivation. In several parts.
Hello, you have 2 minutes more to finish your presentation.
So let me, maybe his internet has just fallen. So basically the findings, Abid, you let me know if you want to continue.
Oh, sorry. Yeah, I can continue now. Sorry for the inconvenience. So as you can see, the first part indicates that commercial flower cultivation. As you know, in several parts of our country, flower is cultivated commercially, and those flower is sold all over the country, and sometimes they are also exported to the foreign countries. So in that sector, the treated fecal sludge, if the fecal sludge are treated properly, they become compost, and those compost can be used in that commercial flower cultivation sector. In the second part, as you can see, treated fecal sludge can also be used as briquette, and as you know, briquette contemplates a better cooking system which reduces the indoor air pollution or household air pollution, and thus fecal sludge can also contemplate circular economy in this way. And in the third way, we are mentioned that it is based upon further policy. That means there is no existing policy currently in our country, but if we can establish a policy, this treated fecal sludge can be used as fish food, which can contribute in the aquaculture sector of our country. And there are some other analyses from our study. Before going to that, let me show you these three pictures. As you can see, the left picture indicates this is a high capacity sucker pump which can collect fecal sludge from the containment in a very efficient and fast way. And the second part is a vacuum cleaner, or generally known as vacuum tag, which actually carry the fecal sludge to the treatment plant. And this vehicle can access narrower road in the peri-urban area of our country. And the third picture, the below picture, also is kind of a similar vehicle, but the difference is this vehicle is run by tractor, which is more suitable for the rural area of our country. So these are the innovations which we are working on to contribute in the fecal sludge management sector. As you know, Practical Action Consulting is a consulting arm of an international NGO. In this project, we are being funded by Bill and Melinda Gates Foundation, and this project is titled as Upscaling Best Practices and Continued Support in Faridpur City, Bangladesh. And Practical Action is implementing the municipal level activities. The Metal Private Limited is one of the first business entity who are interested to intervene this FSM market to commercialize.
Only 1 minute left. I give you 2
yes,
minutes.
I am going to. Okay, thank you for giving me the floor. And as you can see, the present FSM market works around 500 million Bangladeshi taka in Bangladesh, and the after sales services can also contribute better in this sector. And we are not stopping here. We are also trying to generate more innovation, and we are trying to engage more people in this FSM sector. And in that regard, we are arranging a Sanitech Idea Hunt competition where 10 universities, the engineering universities, science and technology universities, and agricultural universities of Bangladesh are participating, and they are trying to generate new idea to contribute in this FSM sector. At this stage of the presentation, I would like to request the co-author of my co-author Sonia Shahid to carry on the presentation. Thank you everyone.
Thank you, Abid. To quickly conclude, I would like to just recommend a few steps to the commercialization process. Acknowledging the human factor is very important. One step towards it is the service level agreement that we have done, where the sweeper and the service providers can work closely with the municipalities. Secondly, ensuring effective vocational training would be very important to ensure the bargaining power of sweeper cooperative and associations. Recognition of the sector as a productive contributor to the economy's GDP and ensuring proper policies has been undertaken by the government is also very crucial. Developing the social infrastructure and demand creation strategies to support the private sector. In conclusion, fundamental science and applied research coupled with the market and customer needs and the process of technology maturation and through commercialization will be key. Will be key to the success of establishing a strong value chain.
You are out
Thank
of
you,
time.
sir. Thank you for giving
Thank
us
you much. But I have 2 questions.
Yes, sir.
First of all, for what purpose you prepare this technology? It will be used in agriculture as organic fertilizer.
Sir, it would be used as to transport fecal sludge from the homes as input for fecal sludge treatment plants. So right now we know fecal sludge is being dumped into the rivers, which is environmentally not safe. It is a key resource. It's a key input for many industries, which is not being recognized as such. For example, the flower business. It's a key input for the flower business, and it's free for everyone to actually use from the homes. So the proper infrastructure is necessary.
But I am very concentrated to one point, that this fecal sludge, when you are sterilized, I don't know, you sterilized or you pasteurized this, I don't know, that you didn't mention well what the disinfectant technique used in this sludge preparation, because we know that if you are going to prepare a sludge for agriculture using materials, it means you have to be very careful for 3 points. First, the pathogens free. Second, heavy metal should be at minimum level. It means we are not going to accumulate the heavy metal in the soil when treated with this material. The third, organic molecules. It means the sludge should contain not any organic compounds such as hormones. So did you are sure that these 3 points are involved in your sludge? Because if you contain, or if your sludge contain animal hormones, it means it will be very dangerous to be used in agriculture, or even if you destroy this material in the river or any natural water resource, because it will cause a very high effect. And the heavy metals, what about the heavy metals? Because you are not going to select the sludge from at home. You select the sludge from the main pipe, and main pipe contain many contaminated material.
Yes. Sir, the technologies we are developing are both where we collect it from at home as well as from the pipes, and there are a few more technologies that we are working with.
I didn't understand from at home. What do you mean by at home? It means at home you have two ways for liquid and for sludge.
Yes. So every home has a septic tank. So because the homes are very isolated in Bangladesh, a lot of the homes do not have connection to the main sewerage system. So these vehicles need to go to the to each home and collect. So they do it once a year and collect the fecal sludge and transport it, contain it, transport it to a treatment plant. Exactly, sir, as you had said, and treated it in a way so that the metallic parts and all the impurities are separated, and the water is separated, and sludge can be treated. There is several processes that are followed to ensure the safety of this sludge to be used as a compost.
It is
Yes,
not. It is not a expensive technique, because normally in anywhere all over the world that the sewage material is going to the main pipe, and main pipe go to the sewage plant for clearing the water. And this, I think, it is cheaper than these two ways of treating the sewage water.
Yes, sir, we agree. So here, basically, the infrastructure is missing. So our paper addresses that the proper technology development that is contextual to the Bangladesh, to the infrastructure of Bangladesh is important, and also the local human resource development is very important to ensure that this infrastructure works effectively. So this is the impact of it economically is what we address in this paper, sir.
That's your idea. I can't say anything from a political point of view, because for me it's a little bit strange to do two ways of wastewater at home to be collected annually. It's too much, I think. Forever. Anyone has any question for the presenters? Any comments? If no, thank you very much and have a good luck.
Thank you, sir.
Thank you everyone.
Thank you. Please, any one of the presenters are present here? Again, we start with I didn't hear you. Please, a little bit loudly.
So the next presenter is Bala Murugan S. Is he present?
If the presenter is here, please introduce her or himself. I don't know. Any of this?
Okay, sir. Then with your permission, we are moving to the next.
Yes, we are going to the next.
Yes, sir. The next presenter is Dinesh Kumar M. or Vijay Napoleon.
Barney Priya is available. Barney Priya,
okay,
ma'am.
Okay. So you are going to present the present.
Yes, ma'am.
Okay, so I'm making you the presenter.
Okay,
Kindly check whether you can share your screen.
Yeah, wait.
Please, can you tell me your name or your title?
Barney Priya, sir.
And your lecture title?
Carbon neutral forming, a pathway for climate change mitigation.
Yes. Please, you can stop.
Yes, sir. The screen is visible. Ma'am, whether my screen is visible?
Yes, it's pretty visible. Just make it in the presentation mode.
Okay, wait 1 minute, ma'am.
Yes, please.
Yes, wait a minute.
clear. I can see it.
Yes, sir.
And I can hear you.
Okay. Good evening, everyone. Myself, Barney Priya. I'm here to present about carbon neutral farming, a pathway for climate change mitigation. Ma'am, can you please present because I can't able to change my slide, ma'am. Sorry for the inconvenience.
Okay, you are okay. You are on the line now.
Yeah, sir, but I can't able to change my slide.
Just use the arrowheads, ma'am, in your keyboard, as because we are not having your presentation with us, or else we would have presented from our side. Just check from the arrowhead.
Okay, ma'am. Okay, ma'am. Wait a minute, ma'am. Yes, ma'am. I can change. Is it visible, ma'am?
Yes.
Yeah, we are good to go. Please go.
Yeah, okay. Okay, sorry for the inconvenience. So climate change and global warming. Climate change and global warming, these are the two major challenging issues for the human beings in future. Change in a usual weather found in a place is referred as a climate change. Though it occurs in a natural pattern, it attains a sudden attention throughout the world because due to its accelerating changing pattern and global warming effect due to the anthropogenic activity, human activities is becoming a severe threat for nature to balance the greenhouse level in the atmosphere, which will manifest a considerable climate change resulting in global warming. So the anthropogenic activities which is responsible for the greenhouse gas emission is energy sector holds a major dominant share of about 73%, followed by 12% by agriculture sector, and 6% is due to the land cover and land use change pattern like deforestation, and 6% is due to the industrial processes, and 3% is due to the domestic waste generated by the human beings. It is evident that next to the energy sector, agriculture sector shares a major role in the greenhouse gas emission due to the human activities. So purpose of this study is to achieve a carbon neutral farming in agriculture through sustainable farming practices, and to prove that by lowering the greenhouse gas emission in agriculture sector, we would positively lower the climate change problems. So we have selected a grapeyard of area of 1 acre in Dindigul, having an geographical coordinates of latitude 10° north and longitude of 77° east, having a with tropical climate with an average temperature of about 27.8 degrees Celsius and annual rainfall of 717 mm. So the conventional practices carried out in the farm is first they prepared the land by tillage practices to remove the previous cultivation crop and remaining all other weeds. Next to the tillage practices, they have constructed trellis structure which supports the growth of the grapeyard. And after constructing the structure, the plantation is done out usually between December to January, followed by an irrigation activity. So carbon footprint auditing, it is carried out to find out amount of greenhouse gases emitted in the farmland starting from cultivation to harvesting. So in a grapeyard, it takes around 120 days for the grapes to harvest. The possible greenhouse gases emitted through the grapeyard is 49.2% of nitrous oxide, 34.4% of methane, 14.1% of carbon dioxide, and others it include like hydrofluorocarbons if the grapes is stored in that on-site using refrigerators. So from the study, we identified that conventional tillage practices, improper irrigation practices, excess use of fertilizer, and usage of fossil fuels to run the farm equipment are the major reasons for the greenhouse emission in the grapeyard. So the practices need to be carried out to attain a carbon neutral farming is like optimizing the irrigation process, renewable energy adoption, reduced tillage practices, cover crop management, and manure management. Let me see it one by one. So first is in reduced tillage practices. So the conventional tillage practices which is carried out now is causes land to loosen its trapped carbon dioxide and nitrous oxide, and it also makes this loses the soil fertility and carbon sequestration capability. In also in a long term, when we go for a conventional tillage practice, it also decreases the soil organic matter and disturbs the nutrient cycle of the soil. So the farmers need to invest more money on fertilizer to ensure the needed nutrition for the grapes nourishment. To avoid the greenhouse gases emission due to the tillage practices, we suggest to go for an reduced tillage practices, in reduced tillage or no tillage practice. By doing so, it not only stabilize the soil bonding and carbon sequestration, it will also reduce the fossil fuel usage for tractors and power tillers used for the tillage practices. The next is in manure management. Manure management is most important. Manure is the most important thing for an plant's growth. In particular, nitrogen is a very essential element for a plant growth and development. In the case of excess application of fertilizer, excess nitrogen is lost in the form of ionic or gaseous form through leaching and or volatilization. It would affect both the soil and the groundwater. And also the excess application of nitrogen fertilizer leads to eutrophication, which affects the aquatic ecosystem, and it also contaminates the groundwater, which causes like some hemoglobin disorders to the human beings. On the other hand, lower application of an nitrogen fertilizer, which causes an nitrogen deficiency to the plant, which affects the growth and yield of the plant. So we suggest to go for an organic fertilizers because they can adapt naturally, get adjusted to the soil, and excess nitrogen can be easily eaten up by the microbes compared to the synthetic fertilizers. As an added advantage, this would also reduce the greenhouse gas emission from the production and transportation of the synthetic fertilizers. So next is an optimizing irrigation practices. Generally, flood irrigation is used for the cultivation. In flood irrigation, most of the water is lost in the channels before it entered to the cultivable land. So it requires more water. So it's the graph itself shows that usage of drip irrigation reduces the amount of water required in all the three seasons like summer, winter, and rainy. So when the amount of water required is reduced, it itself proves that the energy required for pumping the water is reduced. And then like increased moisture content accelerates the microbial respiration of an organic matter, so which results in an carbon dioxide emission. Similarly, it is also influenced
Sorry
the
for the
micro.
interruption, ma'am. You have 2 more minutes to go.
Okay, ma'am. So likewise, the soil moisture content is important to be maintained at a correct way. Then fuel management, we use tractors and other equipments using fossil fuels. So when we adapt renewable energy like natural gases, we can emit 60 to 70% of the greenhouse gases from the transportation of the agriculture crops. Then resultant discussion. So this slide shows that the suggested alternative methods could definitely reduce the amount of the greenhouse gases emitted from the used in the conventional process. This alternative method will definitely reduce the level of the greenhouse gases from the agriculture process. So, but it is difficult to estimate the amount of manure required for land because it changes from place to place. The above suggested methodology will reduce around 55 to 60% of the carbon dioxide and other greenhouse gases. To sequestrate the balance of carbon, the farmers can go for an cover crop management. So we will conclude that we found that conventional practices used in farming produce more greenhouse gases than the suggested alternative method, and also it not only it's benefit for one farming ecology, it also saves money for the farmers since all the proposed alternative methods are sustainable and nature oriented steps. And it is obvious that attaining carbon neutral in agriculture state is a lot more easier and cost efficient comparing to any other sector. So scope of the study is because this type of methodology can be adopted for various crop varieties, and it also reduces the greenhouse gas emission to a greater extent, especially in India, because India stands second in holding arable land of about 159.7 million hectares next to United States. If we practice this kind of sustainable methods, which it will greatly reduce the greenhouse gas emission, and we will have some remarkable progress in climate change and global warming. Thank you for giving me the opportunity.
Yeah, thank you very much for your interesting topics. And due to my job, I am interested in this topic too. because I work too much about the climate change and the soil quality. Can you tell me how we know that the climate change is due to the human activities, whatever the activity? And can you tell me that how climate change can affect the soil quality?
Sorry, sir, can you repeat once?
The question I'm once again. How can you tell us the climate change, how can change the soil quality?
Climate change? Sorry, sir, I couldn't hear you properly. Sorry for asking again.
My question is, how can climate change
Yes,
cause
sir.
changing in soil quality? Soil
Circle
quality.
quality.
Soil quality. Yes.
Soil quality, yes, sir.
Yes. Yes.
So, mm, so like soil quality, all the we use of nitrogen fertilizer, excess use of nitrogen will will definitely reduces the soil organic matter. So as when the organic matter content is reduced, it
I'm talking about,
the,
excuse me, my question is what,
yes, sir.
how can climate change
Yes, sir.
can change the soil quality? Not applying the
Soil quality.
fertilizer. I'm not talking about the human application.
So
I'm talking about the climate, the weather, the
ozone,
meteorological.
yes, sir. Acid rain. So due to human activities, there are various environmental problems like acid rain and ozone depletion. Like acid rain causes the soil fertility low. Soil quality gets reduced due to the acid rain. This is because of the anthropogenic activities and emissions due to the human activities. So
Yes, that's right.
this is the
That's right.
reason.
Yes, that's right. That's right. It means the emission of CO2, SO2, NO2, or
Yes, sir.
NOx.
Yes, sir.
Generally,
Motion.
in the presence of precipitations, it means all the materials coming to the soil, and in this case, two ways of changing the soil quality:
Yes,
increasing
sir.
the mobility of heavy metals. If there is high amount of heavy metals, it will inhibit the plant growth. Second, the pH of the soil will be reduced, and in this case, it will be more acidified, and the plant growth cannot be grow well. Thank you
Yes, sir.
for your testing material. Can if
Thank you,
anybody
sir.
has a question or
Thank you.
comments, any question or comments? If there is no, it means we are going to the third lecture. Any of the presenters are there? Thank you very much for your amazing lecture.
Yes,
Thank
sir.
you, Bhavani Priya madam, for your excellent presentation. We shall move on to the next presenter. Kindly unmute yourself and stop sharing your screen. The next presenter is Liana Kartvelishvili from Georgia. I think that's the correct pronunciation. Are you present? Liana Kartvelishvili, Kurdashvili, Georgia.
No, it's not there.
Okay, so we are moving to the next presenter, James Carlo P.
Yes,
Price. Are you
yes,
present, sir?
maybe it's there. From Philippines. James,
James Carlo P. Frias, Philippines.
antifungal, antifungal activity
Yes.
is not there.
Okay, sir. Then we are again moving to the next
Studies
presenter,
on
M. Bose.
Egan.
M. Bose S. Datta P. Bhattacharya from India, studies on bioremediation. Any of the presenter present?
Is not there.
No. So moving on to the next, Niruban Chakravarti.
And environmentally
Asi-
present.
yes, Asir Ramesh from Karnataka, India. So, sir, once again, I am calling Mr. Balamurugan S. Mr. Balamurugan S, are you present?
Economics of nutrient.
So, sir, in this session, we have completed all the presenters, those who are present. 4 to 5 presenters are not present. So, with due permission of you, shall we wait or move on to the question answer session?
As you like. So we lost 15-20 minutes.
Yes, sir, we are having time.
We have time. We have time.
So, sir, we can wait for 10 minutes for the presenters to wait.
Okay,
Yeah, it's from Abhijit Hajra.
If
It's from
anybody has,
Abhijit.
yes.
Yes. Yeah, sir. Which paper are you there? Like, are you presenting?
There is a paper naming an environmental friendly process pathway for safe disposal of paddy stubble. On the last name on the in this session.
Okay.
It's an
In the name of
environmental
Nirubat Chakravarti.
Yes.
Okay. So, sir, I'm making you the presenter. Kindly go ahead and please check that whether you can share your screen.
Okay.
Take care about 10 minutes only.
So, you are now the presenter. Kindly check if you can share your screen. Yeah.
Can you share my screen?
Yes.
The screen is shared. Just make it in the full screen mode and please go ahead. We are good to go.
Okay. Thank you, ma'am.
Thank you. Can start, please.
So, good evening, everyone. First and foremost, I'd like to thank the organizer of 10th IconSWM-CE 2020, myself Abhijit Hajra, and research scholar from CSIR-CMALI, India. So today I'm here to present a short review on the environmentally processed pathway for safe disposal of crop residue. So these are the points where we're going to discuss in upcoming slides. That is what is the crop residue, status of generation, and how it's affecting our environment, and alternative use of these crop stubbles. So first, the cultivation is one of the profession which was practiced in throughout the world, and you can say that except the Antarctica, every continent practices this occupation. So there is a crop, then there will be residue. Like any fruits, leaves, stakes, staples can be considered as a crop residue after the cultivation. This is a huge amount of part of the crops which will be left over after this. And with the emerging world population, the demand of food is increasing, and you can see from this plot that how from this era like 1974 to today 2020, how the food increase in the food demand. So in also there is a huge pressure on the agriculture industries, so the crop production rate is also increased, and that's why concomitantly the increase in the crop residue also increased. So these are a small diagram which showing that how the generation of food waste being generated in India from 1950 to since its independence to today, and this is the trend how it's increased, and totally around 750 trillion grams of waste being generated during this time. So if we see the in a summarized view for the generation of the crop residue in India, so you can see this diagram from 1994 to in 2006, only in the 26 years is enormously grows to around 500 to 600 million tons per year. So which is around the 30% of the total global version. And if we go for the state-wise generation, the few state are the bank of the river, Ganga river, and even the northwest states like Haryana, Punjab are mostly emerging, the generating the higher amount of crop residue. And most you can see from this chart that most of the residues are being burned away, not being processed scientifically, or and which causing various problems. So for that we can easy to see these kind of headlines in our India, that a huge amount of paddy stubbles or white stubble crops residue are being burnt away, and that's causing severe problem in not only in the states of Punjab and Haryana, it's also affecting the climate or the weather in the Delhi, and causing serious smog and fogs. So what happened when he burnt crop residue or paddy stubbles? It's not only affecting our environment, it's also causing loss of various nutrients which can affect the soil fertility. Even agriculture industries is considered as one of the greatest GHG, greenhouse gas contributor. It's contributing around 12% of total GHG emission. So where a survey of Punjab Agriculture University is suggesting that around 22 million tons of CO2 being generated in the one crop cycle in the 20 days in Punjab. So this is a huge amount. Even in the total the GHG emission from agriculture waste, 11% is only coming from the rice cycle. So these are the huge amount which is causing from the this unscientific disposal of paddy stubble. So these are the data where can you see that how the a type of different types of other GHGs like SOx, NOx, and other VOCs are being generated from the biomass burning from which is generated as a crop residue. So we can say that in summary, not only affecting the regional place where these crop stubble are burning, it's also affecting other places. And you can see the air quality index in India. You can see that around the crop cycle, the region where the main cultivation is occurring are in red region, which is the air quality index is so much the air quality is so much devastatingly low. So even it's considered that it's not safe to breathe in Delhi, like that which is our capital of India. So in nutshell, we can say that the residue burning cause global warming, emission of greenhouse gases, release of particulate matter, and loss of biodiversity and deterioration of soil fertility and other detrimental effect on our ecological health. So what can I do for that? There is a very alternative use of crops or residue. First is the generation of bioenergy. There are few in India. Recently, few bioenergy thermal power plant has been installed which are utilizing this crop residue to generate thermal to electricity. And in few in Punjab Energy Development Agency already developed few plants, and they have target to generate around 500 megawatt of power from this paddy stubble based thermal power plant. So these can be also we take offs and throughout the India to mitigate this issue. Other than that, we can also use develop some byproduct like paper board production from this crop residual. And also the one of the best most efficient way is to is the biomethanation, from where we can there is a survey showing that the paddy stubble has the only paddy stubble have the potential of the generation of biomethane with a rate of 2000 to 3000 cubic tons per tons of biomass. So even recently Haryana government and IOCL come to join handly and to develop 200 combust biogas plants with the agro waste, and which are capacity is currently is around 1000 ton per day to generate that biomass to biogas. Another thing is we can easily convert it to a biofuel like ethanol, so which can be utilized as a blend oil from like petrochemical industries. Here around 260 the potential of the paddy straw shows that it can produce bioethanol at the rate of 2020 to 2060 liter per tons of biomass. Even a few recent Haryana government took the initiative to convert this paddy stubble to biofuel, which will be a very good approach for mitigating the issue related to crops residue. Now, other than this, the other few enterprise or entrepreneurs are try to develop some other commercial products like tableware or food container and medium density fireboard, which can these the products can replace the very use of thermocol and also the plywood, which have a very other detrimental effect on the environment. So other than this, all these application, there will be a surplus amount of crop residue we cannot use as an alternative source of the others product. Then we can utilize that surplus material to convert in bio oil or biochar to through the pyrolysis mechanism. And pyrolysis is considered the one of the thermal procedure which can convert the waste to energy products. And here the two main feature is the oxidant of condition. It's converting this biomass to a very efficient way in a controlled temperature around different process and into biochar and vapor, which vapor can be condensed to convert the bio oil, and also we can get the combustible gas from this. So in this way we can say that in conclusion or in summary, you can say that the crop due to the population explosion, the food demand is increasing. That's why there is a huge pressure on the agriculture industry, and as well as the crop increase in demand in the crops. So there was the crop residual also increase, and which the crop residue is one of the biggest burden to the farmers. To get rid of that, the farmer usually burnt it out in the open environment, and that causing serious health issues or environmental effect to our climate and contributing in the climate change. So so other than burning it out, we can use it in an alternative use, and to that also not only help to mitigating the detrimental effect on the environment, but also keep some revenue to the farmer where which come from where from the crop residues come from. So, and other than the byproduct, the surplus crop residue can also treatment for generating the biofuel through the heat treatment process, the pyrolysis treatment process. So these are the references which are used to prepare this review. So I'd like acknowledge the organizer of 10th IconSWM-CE for providing me this opportunity, and I will extend my sincere gratitude to my director of the Institute CSR-CMRI, Professor Dr. Harishirani, and also thanks to my supervisor, Dr. Priyabhata Banerjee, and Dr. Naresh Chandra Murmu for guiding me to carry out this work. And I will acknowledge CSR and India for providing the financial assistance. Thank you for your patience.
Thank you very much for your interesting topics. And yes, this is the day of how can we convert the waste to energy. And energy not only as electricity or heating, but also as a soil productivity, because soil electricity gives the energy for us in form of food. Can you tell me, please, that which is the most important and cheaper method to use this plant residual? Can we use it as a source of electrical or heating, or better to give it to the soil as organic fertilizer?
Okay, so there is a various kind of application, among which it can
What is the most
for
cheaper, not expensive?
Yeah, sir, according to survey, the biogas generation will be cheaper because the already that's for that reason the Haryana government and IOCL took the initiative to set up 2,000 of plants, to develop 2,000 plants for generation of biogas, which will be utilized as a option for the CNG, sir. So this will be the very cheap method to convert this the biogas. Other than this, is already few plants in Punjab or where they are converting utilizing the crop residue like
fermentation, we can produce the biogas, and from biogas we can go whatever any way we can use as other energy sources. Thank you for your interesting topics. The plate now for thank you. The plate now for the our colleagues in the hall. Any question or any comments, please? Any comments? Questions? If there is no, thank you very much for interesting topics, and have a good luck.
With due permission of chair, as we are not having any question, I shall quickly recall all the names, those who have missed their presentation. Kindly check if any presenters are present. I would like to call Mr. Bala Murugan. Are you there? Moving on to the next, Liana Karthavelli Shivil from Georgia. This is the second time a final call to you, sir. Are you present? Moving on to the next, James Carlo or P. Frias, not present. And the last, M. Bose S. Datta P. Bhattacharya from India. So, sir, as we are having, as we can see that we do not have these presenters present in this session. So, I would hand over myself to Dr. Aparoop Konar to kindly preside over the program.
I request Professor Hosham Please present the chair summary and conclude the session in 5 minutes. Before we leave the session, I request all the delegates to open your camera to take a group photo.
Open the camera. Okay.
Professor
Just a
Hosam,
moment.
your camera is open. We can see you.
Yeah, okay. Just a moment. I tried. My camera is open. Can you see me?
Yeah.
You see me? You can see me?
Yeah. Yes, we can see.
Okay.
So we are waiting for your chair summary and then we shall move to the group photo.
Yes. In this section, we hear about the climatic change, the role of climatic change on the agriculture, and the role of fermentation to produce energetic source instead of waste, agricultural waste material. And also we have here about excuse me, the new technology for fecal sludge, and most of the owners of the lecture, they are PhD students, as I hear, and they are in a good step to win their PhD degree. All these topics are important today or nowadays in the global point of view because of the environmental problems we have increasing in our population, and also the climatic change is one of the most important problems all over the world. Due to climatic change, there is many factors can come out by increasing the industrialization, gas emission, carbon dioxide, sulfur dioxide, and nitrogen oxides. By or through the raining, it means acid rain can be reduce the quality of the soil, and by this way we are going to miss our food. But there's another point of environmental problem, that is the drying, the drought. The drought, some of the agricultural land, it was land, agricultural land, it was a producer, but now according to the increasing in temperature and shifting the rainfall, they become dry, and in this case we have to search about any way how can we develop a new agricultural land, but not by cutting the forest, because the forest in our global is working as the lung of our body. If we are going to make deforestation, it means we are going to reduce the oxygen tension, and if oxygen tension is reduced, it means we are going to have a very big problem with pollution. One of the most important also topic that how can we reduce the sewage disposal. The two presenters from Bangladesh say new techniques. How can we, or how can they reduce the sewage fecal sludge, and how can they use it somewhere in their country? But I think that this kind of techniques, it will cost too much, because from public health view, if we have one way for sewage water which go to the sewage plant treatment, once there they can separate the solid material from liquid material, and liquid material can be treated, and can be organized by physical, chemical, and biological treatments. And in this case, the outlet of this sewage water can be used in irrigating the forest soil. If there is no high level of heavy metals or contains any pathogens or containing any hormonal content. So we can use this water for, as I told you, forest irrigation. Also, we can use sludge or the solid material. We can convert solid material to waste water sludge, and in this case, according to the UN Assembly as well as the European derivatives, we can use the sewage sludge in agriculture if there is no harmful or hazard material contained there, and under the regulation of the agricultural ministers in all over the world, they agree to use the sewage sludge under specific conditions, and those also it is important to increase the soil quality, which are going to be bad by using the inorganic fertilizers, because inorganic fertilizer, yes, they supply nitrogen, phosphorus, kalium, and etc., etc., etc. to the soil, which can be absorbed by the plant. But during the time, this will cause soil acidification. And during the time, it means the microbial population in the soil, which play an important role in the soil, will be reduced. In this case, the biotransformation of the organic material to inorganic material to supply again the soil quality, or the elements taken up by plant and increase the soil quality, it will be also reduced. So it is a very linked problems, and we don't like to miss any ring of this of this
Thank you, sir.
lens.
Thank you, sir. We are waiting for your smiling face so that we can take a group photo and then we can conclude the session.
Yes, please.
Just a second, sir. Yeah, we are done with the photo, sir. Thank you very much. Over to Aparoop, sir. Please, sir, conclude the session.
Anyone would like to give any comments? Any one of the presenters are there? They would like to give their Miss lecture? We are ready to hear at least one or two. We have time.
But we do not have them on the session. They are still missing from the session.
Okay, they are. It means we are now out of.
Maybe next time, sir.
Okay, thank you very much for your help.
Thank you for your wonderful and informative speech, sir. So, sir, let us conclude.
Thank you very much.
We
Thank
shall
you, sir.
meet.
Thanks.
Thank you, sir, for your remarks. Now we close the session. We request all the participants to please join in the next session as per schedule.
Okay. For me, I have to leave because I have a lecture. Okay. Thank you very much. We can meet tomorrow morning. Okay.
Yes, sir. Sure.
Bye-bye. Bye-bye.
Bye-bye. Good night.
Bye-bye.
This conference will now be recorded.
Good evening. Good evening. I, Joita, resuming today's next session, TS13 on wastewater. I would like to invite Dr. Sunil Pandey to chair this session. But before this, I would like to remind a few points to all present here. The participants are requested to mute microphone and close camera. Speakers may be unmuted when requested. Please adhere to the timeline to avoid delay. The presentation for speakers is of 10 minutes.
This conference will now be recorded.
Question answer session will be the end of the session. Questions should be written in the chat box to the specific speakers. The chair individually will rate each presentation on the rating sheet provided to user. Chair kindly write their chair summary of the session with a few key outcomes and present at the end of the session. Filled in the rating sheet and chair summary will be sent to us by email. I would like to request all presenters kindly confirm their attendance in the chat box as I already requested earlier. So please confirm their presence in the chat box so that we can call you accordingly. With the due permission of the chair, we will start our technical session. Dr. Sunil Pandey, sir. Dr. Sunil Pandey, sir. Dr. Sunil Pandey, sir, are you here? Okay, sir. Dr. Sunil Pandey, sir. Maybe there is a technical issue. I'm asking Professor Ghosh, sir, will you? Okay, sir.
Good evening, Pandey sir. We can see you and you have unmuted yourself, but there is no audio from your side. I would request Pandey sir to say something because you are unmuted, sir. But we are not getting any audio from your side.
Dr. Sunil Pandey, sir.
can hear you. Can you hear me?
Sir, yes, sir. Yes, sir. You
Hello.
are audible. Yes, sir. You are audible, sir.
Okay, okay. You're fine.
Sir,
Thank you.
please say something. Uh, you are the chair of this session, sir. We're inviting you as
Yes.
chair.
Good. You can hear me, no? Hello.
Yeah, we are
Yes,
good
sir.
to go. Please go ahead, sir.
Sure.
Sir, we can hear you. Please go ahead.
Shall we start?
Yes, sir.
Okay. So good evening, everyone. And sorry, let me switch on the video. Yeah, it's my pleasure, and me along with my co-chair, Dr. Majumdar, who's also my senior uh, colleague at various points, are very pleased to join this session as a chairman for the chairpersons for the session, not getting into gender issues. The session which we are supposed to manage is on the wastewater. And as I see the structure of the session, it is to begin with around 15 minutes. We'll keep it to 12 to 15 minutes keynote address, addressing the issues and challenges on wastewater management for the country, for the developing country, especially for the country like India. And followed by Dr. Majumdar then would invite presenters one by one and give them directions for presentation, and will complete the presentation for the session in the given schedule, and accordingly then we'll kind of end the presentation session with the session summary. So for the keynote address, I'll ask Dr. Majumdar to present his view first, and followed by my views on the keynote issues. Dr. Majumdar, please. So you're muted.
Sir, please unmute yourself, sir.
Okay, so good evening, everyone. Is there any specific keynote speaker? Because in the chairman's note, it's not mentioned directly that we have to give the keynote. So we shouldn't, feed on someone else's food as such. So is there any specific keynote?
No, sir. There is not. There is nothing mentioned. But, sir. If you feel like, sir, you can give sir a keynote speech, sir.
Okay, so this is kind of an unorganized keynote speech, whatever we see around us, and because this is an international webinar where so many participants from different countries are there. So I would also like to give a view about what's happening here. Well, friends, it's a pleasure to be here. And wastewater has become a very important issue. And you see, if we look at it across the world, there was a time when from small plants or small facilities, the tendency was to go for bigger facilities and bigger facilities. So in a large town, for example, there would be 1, 2, 3, that's all. Of course, in India's capital town, Delhi, capital city, Delhi, there are 17 so far. But these are very large wastewater treatment facilities. Over a period of time, one has realized that this may not be the only solution. So there is a trend backwards again. So we are again looking at possibilities to decentralize the facilities so that kilometers on of conveyance sewer lines need not be constructed and maintained, which are very difficult, especially if the cities and the towns are not planned right from the beginning. Then putting up a sewer line, especially with hard pipes, it's a very, very difficult task as such. So therefore, there is a tendency again to decentralized to the extent possible, and this is very exciting in a way. So in a decentralized facility, one can look at small clusters, or can look at ward level in terms of municipal jurisdictions, or in terms of a certain zone of a city. So therefore, as per the facilities available, as per the wastewater to be treated and the strength of the wastewater, different kinds of systems can be developed. And particularly if it has to be in a retrospective kind of installation, then it can be very useful, very handy to have decentralized facilities as well. Because to run through a built up town and digging deep and deep, and as you move towards the sewage treatment plant, suppose the sewer line goes 10 kilometers, and with a very small gradient also, if one starts at 1 meter depth, at the end it may go up to 10 meters depth and so on. And in the intermittent places, one has to have pumps to lift up the sewage and again put it at a slightly higher level. So this becomes pretty difficult and tedious. So therefore, this option as such is developing. Therefore, I would like to mention here and place it before you that we should plan as per the requirement of the site, requirement of our city, requirement of the population, and also the kind of water supply which is available. Say, for a normal hard pipe sewer line, 100 to 125 liters per capita per day water supply is required, which again is not easy in every town today. Even in our country, in many places, it's becoming very, very difficult. There are places where water is being brought by tankers, by even rails. So you can imagine that providing 100 liters per capita per day would be a very difficult thing. So therefore, there have been, if we very quickly track the developments of this thing, for the large scale facilities also, different kinds of sewage treatment facilities were developed over a period of time. And initially the aerobic system called ASP, or activated sludge plant, that was quite popular till the time that around 1979-80 came the UAF and the UASB. So UASB was possibly a very handy thing later on, but it took quite a bit of time. It took almost 10 years to percolate down to the ground as such. But it is very handy in the sense that the energy requirement is very low. So therefore, lots of UASB plants are being made now. And Professor Littinger, who had actually developed it around 1979-80. See, UAF and UASB were developed almost at the same time, 1979-80. And UASB has really been very handy as such. And UASB can also be utilized for decentralized facilities. See, Dr. Pandey is here. They have a system wherein they use this for small biogas plants also. They have a system called team process. So in that also, actually UASB is used in a biphasic manner. So what I want to say here is, depending on your situation, meaning number one, water supply, number two, the way to get the pipes through, right, and the kind of treatment facility which would be required if it is in a larger facility. So all those things need to be planned. Otherwise, please plan in a smaller way, and it can be a small cluster, even for 10-20 households, 500 households, 1,000 households. It can be in any numbers. The planning is, it's very flexible kind of system. And at the same time, there is another system called small bore sewer. Again, the hard pipe sewer, their gradient is not changed. They go by only, the same gradient till there is a pump, the sewage is lifted and put at a higher level. Again, they start. But in a small bore sewer, they use flexible piping so that they can negotiate small bends and small undulations. So therefore, small bore sewer also is a very handy companion of decentralized facilities. And I would like to finish with one particular system, which is called DWATS, or decentralized wastewater treatment systems. In fact, around the year 94, 95, we were, we were very much involved in bringing that to India also, develop it. First we called LOMWATS, or low maintenance wastewater system. And then because the word low was not liked by many people, so we changed the name to DWATS, or decentralized wastewater treatment system. So again, decentralized wastewater system, or DWATS, is a very, very flexible thing, a very flexible design. It's not a particular design, but you can design as per the situation. It can be for a hostel of a school or a college. It can be for a colony. It can be for a housing society. It can be for a part of a town or a city. So I'd like to end here. What I've just summarized, that the basic thing is to plan, look at water supply first, look at the land available for getting your pipes, look at the town or city or village, wherever you are going to put the sewerage system, then plan accordingly. Okay? Thereafter, you will be much more successful, and it will be a very experience for all concerned. Thank you very much.
Thank you,
Dr.
Dr.
Pandey.
Majumdar. Sure, sir. Thank you, Dr. Majumdar. And with this opening, I just would like to add that emphasis now obviously will be also on not only providing convenient decentralized systems with a lesser cost and lesser footprint, energy footprint or environmental footprint, but also on the resource recovery. In the wastewater treatment system, traditionally over the years, we only have been talking of water recovery, water reuse, but time has come. Researchers everywhere are looking at how different nutrients, how different other useful chemicals, in addition to energy, can be recovered from wastewater management while treating the wastewater. So with this, I hand over to organizers. Would you like to call everyone for presentation, or how do we process them?
Yes, sir. With your permission, with you, Panda sir, and the Majumdar sir permissions, we will proceed to our technical session part. Sir, shall we?
Yeah, you
Okay,
all
sir.
use. Yeah.
Okay, sir. The technical session is about to begin. The first presenter of this technical session, Dr. Bindu Mala Thakuri. Are you present, ma'am? To present?
Yes, ma'am.
Okay. So I'm making a presenter.
Okay.
General ground rules are we have 8 to 10 minutes for presentation, followed by 2-3 minutes for question and answer. Is that right, Jayata?
Yes, sir. Question answer session at the end of the session is
Okay.
there.
Okay.
And yes, sir. The question answer need to be put in the chat box, and we will verbally. Yes, sir.
How
So
many
please
are there?
continue. Please
9 or
continue,
Okay.
Dr. Bindumala Thakri.
Okay, I will continue.
And the next 10 minutes is yours, ma'am.
Okay, thank you so much. The title of my presentation is Energy Waste to Energy as an Alternative Energy Source for Waste Management in Nepal. Where is the next slide? Why it's not moving? The background, increases in population, rapid expansion of urban municipalities, economic growth increases the solid waste and also the energy demand, especially in Nepal, environmental problem, which is created by waste and public health risks are the major problem. Our country mainly depends upon the traditional energy and imported fossil fuels. Despite there is a link between the waste and energy, Nepal, we are not still practically used, and it is still viewed as inferior. So Nepal's economic and social development is being hampered by inadequate energy supply. Therefore, waste to energy is an alternative energy source in achieving our goals of waste management as well as in energy security. So my research question is, what is the current status of waste management in Nepal, especially like generations, waste characteristics and disposal methods, and what methods of the waste are appropriate in the context of the Nepal? So as we know, like if the solid waste are not managed well, it has a directly effect on the environmental and health issues. So from the healthcare to the constructions and other kinds of the hazardous waste directly effect on the environment. And why waste to energy? There is limited resources in our environment. There is a water shortage, increases in greenhouse emissions, and increases in energy consumption. So why the waste to energy? Is there any solution? So we are hoping using waste as energy, we could some solution for environmental, economic, and in terms of the energy. So there is a recycling principle, for example, reduce, or reuse, recycle, and recovery. In terms of the energy mix in Nepal, the energy, there is a primary energy which is used by the biomass and biomass energy, and secondly, the most of the energy used is focused on the traditional and transportation energy. So this is some of the current status of Nepal, like some background, physical status, and disposal method. We are about 29 million population with the 40% of the urban area, and then we have around 1,000 GDP. So in terms of the waste generation, we can see about 524,000 tons per year. In terms of the per capita, which is about 4 gram per day, and when compared to the global, it's not that much. And we spend almost $30 for the collection to disposable, and the mostly disposal methods are the landfill. So this is the spatial distribution, how the waste is distributed in Nepal. So there are not much data in the mountain area. So most of the waste are heavily generated from the lowland and also urban areas. And in terms of the characteristics, like other Asian, South Asian country, we are also, the organic portion is the highest one, which is about 66%, and followed by the plastic is the second major problem, and the paper products. So this is just some of the figure photos I'm sharing how we are doing. So the collection and transportation, basically we are just collecting the all kinds of mixed waste, and then segregate this waste on the landfill site by the manually. And this is just the one of the example of our landfill site, which reflects the condition is very poor. And we do simply unload the waste, spread, and the very simple soil covering, and no other technology. So if we compare the generation in Asia and Pacific, we are not that, we are pretty, actually in terms of generation, we are okay. We are the lowest country among the other, compared to other countries. However, some of the countries like capital Kathmandu and other urban cities generate the lots of the waste. And when comparison, the per capita generation, like Nepal and India is doing pretty good compared to other Asian countries. But the problem is unsound disposable. So when we are about like more than 65% in condition where we disposable our waste in the bad, in not the proper way. And we don't have, unfortunately, no data about the recycling of Nepal. So this is also not good. However, there are very few percentage of the informal recycling and compostings are going on. So we do the waste treatment mostly by open dumping, which is about 45%, and remaining is burning. And we can see sanitary landfill and control is about less than 10%. So I'm just thinking this may be the one of the way to manage the waste. So we divide the municipal waste as organic and inorganic, and organic, general, and the recyclable waste. So general waste we can treat it with the different technology and produce the gas, electricity, and energy. And with the organic, with the biological treatment, gas, and compost. And then the remaining residual is a landfill and for the methane collections. So we have to consider also the economic analysis, especially countries like Nepal, where we are very poor and low GDP. So having incinerations and pyrolysis, both the operation and capital cost is much higher. So we have to, considering the analysis, we have to make some plan. So to summarize, first of all, we must segregate the waste at the source, which is the most essential, and then the suitable methods for Nepal case is composting and anaerobic digestion, and then we can move to the incineration and sanitary landfill. Recovery means the energy extraction from the waste by incineration. We may use incineration for the waste management. However, if we want to have the more energy, we need a more waste. This approach is also problematic. So if reduction, reuse, and recycling do not come ahead of the energy recovery, we may discharge the more waste and combust it. So emphasis goes to the reduction, reuse, recycling, then recovery and proper disposal. So we have to develop our policy mix to implement the institutional arrangement and public awareness, and also behavior changes of the citizenship, our citizenship, and then finally we must have some investment from the private sector to fund the waste and energy for the proper waste management. And this is the end of my presentation, and thank you very much.
Thank you, ma'am, for your nice presentation. Please unshare your screen and mute yourself.
Okay.
So we will move. Yes, ma'am.
Okay.
So we will move to our next presenter, Dr. Somakraj Banerjee. Are you present here, sir? Dr. Somakraj Banerjee. Hello, Dr. Somakraj Banerjee. Are you present here?
I see his name, but it seems maybe his volume is too low.
Okay.
Because he's unmuted also.
Mr. Somakraj Banerjee, please unmute yourself if you are present and raise your volume. Your name is visible in the people's list. Okay. Please make it full screen.
Hello, sir. We are not receiving any audio from your side. Kindly refresh your audio. The screen is visible.
You're not audible, sir.
Am I audible now?
Yes, yes, you are audible now. Please make it full screen.
Yes.
Yes, and the next 10 minutes is yours, sir. Please continue.
Good evening, everyone. I am Samuddra Banerjee from Jyothilakshmi University, and I will be presenting my work on wastewater ultrafiltration and hydrophilicity equipment of polysulfone membrane using polyvinyl fiberglass. So, first we start with what is wastewater. It's a combination of liquid and water transported waste from industrial sources, and it contains organic, inorganic matters and gases. And in this particular work, I will be working with organic matter, that is protein. So I will be working with typical dairy wastewater, and these are the typical characteristics of the dairy wastewater. And the proteins of interest are sedum-albumin, lactoferrin, and lactoglobulin. It works as an antioxidant by protecting lipids from oxidation. So it has importance in food and pharmaceutical industries. So I have chosen polysulfone as the membrane material, which has superior thermal stability, a glass transition temperature at around 200 degrees centigrade, mechanical robustness, and chemical resistance. But it also has some disadvantages, like it is strongly hydrophobic in nature, which limits its permeability in case of wastewater treatment, and poor fouling resistance. So I have tried to add polyvinyl pyrrolidine into the system to increase its hydrophilicity, and I have used polyvinyl pyrrolidine in different weight percentages to see the changes in the system. So these are my aims and objectives. So the primary objective is modification of the membrane with an additive and characterization of the prepared membrane with liquid-liquid displacement porosity and transition test, and to experiment in a wide pH range to find pH dependency of the membranes and the whole separation process, and preparation of modern dairy wastewater and use it for wastewater treatment application by the selected best method. So the material used are polysulfone of 35 kDa, polyvinyl pyrrolidine of 360 kDa, and dimethyl acetamide as the solvent, and deionized water as a non-solvent. And this is the composition given in my membranes. So this is the prepared membrane. The solution was fired in a magnetic stirrer for 12 hours and it was for 6 hours, and then immersed in DI water with with casting and glass plate with 200 micrometer thickness with using phase inversion method. So now I come to membrane characterization. These are the characterization processes I followed. The first comes a liquid-liquid displacement porosimetry. This is my experimental setup, but it's a dead-end filtration module, and with this I have performed all my experiments. Now, these are the SEM images of the three membranes I made, and you can see the finger-like structures in here. The finger-like structures in here are proof uh, of the cylindrical pore structures formed in the filtration layer. Now coming to the um, results of the LLDB process, the percentage number of pores plotted against pore size, and we can see 27% of pores are around 2.25 nanometer, and pore size ranges from 2.25 to 13 nanometers, and the membranes are applicable for ultrafiltration purposes. These are the graphs of cumulative permeability versus pore size and cumulative pore number versus pore size. And from the table, you can see that the mean average pore size varies, gets reduced as I increase the polyvinyl pyrrolidine percentage, and the area of the total area of the pores also increase with the increase in polyvinyl pyrrolidine, which indicates that polyvinyl pyrrolidine increases the permeability of the membrane. So with increasing PVP percentage in the membrane, the total number of pores are increasing. And in our membranes, greater than 90% of the pores lie in the 2.25 to 4.06 nanometer range. There is a marginal decrease in mean pore size from 2.38 nanometer to 2.28 nanometer with increase in percentage of PVP added. Since the total number of pores and total permeability is seen to be increasing, it can be inferred that the addition of the PVP in higher percentage increases the porosity of the membrane. Now, coming to the compaction factor and pure water flux graphs, and from the table we can see that the compaction factor decreases with increase in polyvinyl pyridine, and the permeability of water is also increasing. The equivalent water concentration also increases, porosity increases, and the contact angle decreases, which indicates increase in hydrophilicity with increase in polyvinyl pyridine. So higher amount of polymer additive and lesser time to diffusional exchange in the phase inversion process may be making the hydrophilicity higher. Now, coming to the molecular cutoff determination, a semi-empirical method has been employed in this, where the Stokes-Einstein radius has been used to determine the relation between the molecular weight cutoff and the molecular cutoff of the membranes. So, with increasing polyvinyl pyridine percentage, we can see that the molecular weight cutoff decreases. Now we have made a protein separation ultrafiltration experiment, where we have experimented the reusability of the membrane, and we can see, as in the first run and the second run, the pure water flux and the ultrafiltration permeate flux of the protein is almost retained after repeat usage. And in the second graph, we can see the effect of pH in ultrafiltration of BVA, the bovine BSA solution, and we can see with high pH in basic condition we get higher rejection, and in isoelectric condition we get lower rejection, and with increase in the pressure, the flux is decreasing. The flux recovery is found to be over 90%. The rejection is highest at basic condition and high operating pressure, and rejection is lowest at isoelectric condition and low operating pressure. Now we have made a model dairy wastewater with commercial skim milk has been treated and centrifuged to an after isoelectric precipitation, we get supernatant fluid, which after characterization by Bradford as a method, the protein concentrated was found to be 102.5 ppm. And after ultrafiltration of this model dairy wastewater, we found that at pH 4.8, using TS13 membrane, which has the highest polyvinyl pyridine percentage, gives 74.93% rejection of total protein at 40 psi. At pH 7, the rejection is 79%, which is higher than isoelectric condition. Steady state flux of 9.7 liter per meter square hour at 40 psi with pH 4.8, and steady state flux higher than that at pH 7 has been found.
Sorry to interrupt, sir. You have 2 more minutes left, sir.
Okay. The conclusion is PVP additive has significantly enhanced porosity, permeability, molecular weight cutoff, and BSA rejection and reusability. And higher weight percentage of PVP increases hydrophilicity. Further increase in weight percent of PVP will not be effective. Wastewater treatment gives 75 to 79% rejection of total protein in case of model dairy wastewater, and value of pH of feed affects the separation phenomenon. These are the further prospects.
These are the references. These are my acknowledgements. And thank you.
Thank you, sir, for your wonderful presentations here. Please unshare your screen and mute yourself. With the permission of the chair, we will now move to our next presenter, Dr. Murtuza Ali Sayed. Are you present here, sir? Dr. Murtuza Ali Sayed.
Good evening.
Good evening. Okay, I'm making you a presenter.
Yeah, please, ma'am.
Your presenter, sir. Please
Yes,
share your
ma'am.
screen.
Sure.
And the next 10 minutes is yours. Please make it full screen, sir.
Sure. Okay. Is it visible? Am I audible?
Absolutely visible, sir. You can please continue, sir.
Thank you. So, good evening, everyone. I myself, Dr. Syed Murtaza Ali from National University of Science and Technology, Muscat, Oman. So, today we'll be presenting on our research work carried out on the utilization of agro-waste material as an adsorbent for wastewater treatment. So in our study, the slaughterhouse waste which generated in the Sultanate of Oman was studied using the low-cost adsorbent prepared by using the waste orange and kiwi peels, wherein the slaughterhouse wastewater was treated using prepared activated carbon of orange and kiwi peels using series of batch reactor experiments, wherein the performance of these prepared activated carbon was evaluated in the removal efficiency of various of the contaminants by using various parameters such as dissolved oxygen, chemical oxygen demand, biological oxygen demand, and total dissolved solids, including phosphate content. The percentage removal was determined, and also the experimental data was fitted to Freundlich and Langmuir adsorption isotherms, wherein Freundlich isotherms found to be better fitted for our experimental data. So the background is the waste generated from the poultry industry or in general from the slaughterhouses is increasing with the increase in the demand. Also, this generates a huge quantity of wastewater from these slaughterhouses, which contains several pathogenic as well as non-pathogenic microorganisms. So the direct disposal of this will causes negative impact on the environmental biodiversity. So in the literature, there are several technologies have been reported for the treatment of the slaughterhouse wastewater, including coagulation, flocculation process, and so on, wherein the effect of various factors such as the pH, concentration of coagulants, mixing rate were studied, and also the optimization methods such as response surface methodology were used to optimize the process. The substantial percentage removal efficiency of COD was observed, and also the wastewater was treated using batch sequential reactor system with different types of fibers, biofibers reported. The methodology which is used in our study is methods and materials. The samples collected from the local municipality, slaughterhouses, then the samples were stored at room temperature, and before conducting the experiments, the water samples was filtered to remove the particulate matter, and also the initial parameters before the experiment was measured. So the adsorbents, that is the waste orange and kiwi peels, were collected from the local market, and the parameters, various parameters were studied, including dissolved oxygen, total dissolved solids, and other parameters were studied, which are listed here. For adsorption preparation, the collected fruit peels were washed thoroughly to remove any impurities, then treated with deionized water. Then the samples were dried in order to remove the moisture, and they were ground to the required particle size. They were calcined at a temperature of 250 degrees for about 12 hours to produce the required carbon. Then this was added with the sulfuric acid, and the resulting mixture was kept overnight by refluxing for 12 hours. Then the carbon was filtered, washed with water, and it was heated to remove the moisture content. Then the treated carbon was soaked in 1% sodium bicarbonate in order to remove any remaining traces of acid. Then the carbon was filtered and its pH was determined. Then it was dried, and the resulting activated carbon of both orange peels as well as the kiwi peels were stored for further experimental studies. Then the beta analysis was carried out to determine its surface area. In our experiment, the batch experiments were carried out using the prepared activated carbon, and the calculated amount of the adsorbent were added, and the mixture was allowed under constant stirring. The samples were taken at regular time intervals, and the parameters were measured. The pollutant removal efficiency was determined in terms of the percentage removal efficiency. So these are our results. The percentage removal efficiency was studied in terms of the contact time. So as we can see that with the increase in the time, the percentage removal of the contaminants were reduced. The parameters which studied here were dissolved oxygen, chemical oxygen demand, biological oxygen demand, total dissolved solids, and phosphate. So the percentage removal efficiency increased with the increase in the contact time. So it was considered for 3 different time durations.
Sorry to interrupt, sir. You have 2 more minutes left.
Okay, sir. Right. So percentage removal efficiency and contact time also studied for both the activated carbon of orange peel as well as the kiwi peels. Then the adsorbent dosage was studied for different concentrations of the adsorbent. Okay, so as we can see, this percentage removal efficiency increased with increase in the adsorbent concentration. Then the samples, the experimental data was fitted for LunagJr and Freundlich isotherms. So the results are presented here. So in the final concluding remarks, both the activated carbon samples of orange peel as well as kiwi peel were prepared, and the collected water samples was treated using the prepared adsorbents, and it was observed that the performance of activated carbon of orange peel was better than the kiwi peels, okay, activated carbon kiwi peels, and the percentage removal in terms of their percentage removal efficiency of various parameters studied. Also, the experimental data was fitted to Freundlich and LunagJr adsorption isotherms, and their constants were evaluated, wherein the Freundlich isotherms was found to be slightly better fitted to our experimental data. So these are some of the references. With this, I would like to thank all of you for your time. Thank you.
Thank you, sir. Thank you for your wonderful presentation here. Please unshare your screen and mute yourself.
Sure.
With the permission of the chair, we will now move to our next presenter, Dr. Manjusha Chakraborty. Are you present, ma'am? Dr. Manjusha Chakraborty, Dr. Ranjana Das. Are you present, ma'am? Dr. Manjusha Chakraborty.
Dr. Chakraborty seems to be here, but she's not unmuted.
Okay, sir.
Is there any other author available?
Maybe, sir, there is a connectivity issue. Shall we move to our next presenter, sir?
We will come back to Manjusha later.
Okay, sir.
Sure.
So we will moving on to our next presenter, Dr. Rishiraj Verma. Dr. Rishiraj Verma.
Hello. Yeah, I'm present.
Okay, sir. You are the presenter now. You can present your slide, sir. Please share your screen.
Yeah.
Yes, sir. Please make it full screen. Yes, sir. Just okay. Absolutely. Now the next 10 minutes is yours, sir.
Yeah. Thank you.
Please continue. Please continue, sir. Yes.
So good evening. Good evening, everyone. I'm Rishiraj Verma. I'm an undergrad student at BITS Pilani Hyderabad campus. So as a part of my academic project, I worked on a project titled Modeling Steady State Performance of MBBR Treating Municipal Sewage Water. So as we all know, wastewater is any water which has been contaminated by the human use. The major resources include household, industrial effluent, or or it can include mixture of both also. So wastewater treatment is fundamental duty of our society, as it has many advantages. To share some, one of the reason can be it leads to water restoration in our water cycle, and it also leads to resource recovery, like nitrogen, phosphorus, etc. So as a part of my project, I developed one model which can be used in treatment of water. And for developing that model, I used one software named GPSX, which is developed by Hydromantis company. And using GPSX software, we can design various wastewater treatment plant model, and this software is used in industries also. So the access was provided to us by Hydromantis under educational license. So moving bed biofilm reactor is an economically solution offered for wastewater treatment if the bulk of the pollution load must be disposed. So MBBR system consists of an activated sludge aeration system where the sludge is collected on recycled plastic carriers, generally HDPE, high density polyethylene, and these carriers have an internal large surface for optimal contact of water, air, and bacteria. And these bacteria activated sludge grow on in the internal surface of the carriers, and eventually when the wastewater comes in this tank, it breaks down the various organic matter present, and which and then further the water is sent to the clarifier tank for further tertiary treatment or for release. So MBBR process can be used for a variety of different applications to attain the desired results depending on the quality of wastewater and discharge regulation. So my project our project here included determining those parameters on which we can or by which we can increase the efficiency of the MBBR system. So this is the methodology that we used. We use GPSX software for creating various simulations of various characteristics of incoming wastewater, various aeration rate, and all. So this is the working. This is the table by which we can enter the various characteristics of wastewater into the GPSX software, and here you can enter various characteristics like concentration of urea, concentration of MgCl2 as per your requirement. And this is the working window of GPSX software. On the left hand, you can see various by which we can create the model, and on the right hand side top you can see two windows. One is modeling, second one is simulation. First one is used to create various models, and second window is used to simulate the various results using the desired as per as our desired output. And so this is the model which we used in all our simulations. So here you can see this is the incoming wastewater, followed by the grid chamber, followed by MBBR system, then for secondary treatment or clarifier, and then sludge is removed, and the wastewater is released into the stream, into any water stream. So MBBR gives us two different methods, two different aeration methods. One is diffused air method. Second one is mechanical aeration method. First we will discuss which. First, we as a part of our project, we try to find which method using simulation, which method is better, whether diffused air method or mechanical aeration method. So diffused air method is diffused air method consists of small diffusers present in the bottom of the tank, through which air bubbles are released into the tank, and it has complete mixing from top to bottom, and it has low maintenance cost, but it is prone to greater susceptibility and fouling, and it is less effective in harsh environments. Harsh environments here refers to various presence of various other chemicals. So as a part of our project, we simulated various results, and we obtained this result. Like with increase in the aeration rate, biofilm mass decreased, and similarly, when we use the DO controller, more or less same biofilm mass at different was produced at different airflow, but it was significantly less than the entering airflow method. And similarly, then we use entering KLA method for specific oxygen transfer, and then we observe the similar trend. And coming to the mechanical aeration method, mechanical aeration method is a conventional system which includes a rotating shaft using physically or using a generator. So it has strong mixing and oxygen transfer, but it has lower aeration efficiency, and it gives very unpleasant odors. So so again we simulated various aeration rate, and we saw how biomass is producing, high biomass is producing, and we observed that diffused air method was came out to be better as compared to any other method. So at this part we concluded that diffused air method is better than any other method for using in MBBR. And then from further this point, we used only diffused air method for all other simulations. So
Sir, sorry to interrupt, sir. You have 2 minutes left.
Sir, hello, excuse me.
Thank you, sir.
Hello.
Hello, sir.
Yes.
Sir, you have 2 more minutes.
Yeah, sure, okay. So we observed various results, and we saw that there was no effect on COD, and similarly nitrogen removal was increasing as soon we observed as the aeration rate was increasing, and similarly for total suspended solid and volatile suspended solid, it was decreasing with increase in aeration. And so coming to the conclusion part, we can say that aeration method finding was found to be the most accurate, and diffused air system is the best to use in MBBR, and the COT demand does not change as simulated because of some external factors, also maybe due to denitrification. So the future aspects of this project can be the findings can be verified using the actual lab experiments, and more complex variations can be introduced into the MBBR system, like to obtain various correlation between various microorganism and the pollutant. And these are the selected references that I referred. And I would like to acknowledge Hydromantis company for providing us with the software license, and BITS Pilani Hyderabad campus for all other necessary resources. Thank you.
Thank you, sir. Thank you for wonderful presentations here.
Just a moment.
Please unshare your screen.
I would request all the participants to please keep the time, because I don't want that at a later stage they should be under a time stress. So right from the beginning, kindly look at your time and distribute over the whole presentation. Thank you very much. Please go ahead.
So, okay, sir. Please, with the permission of this chair, we will moving to our next presenter, Dr. Nilofer Nisha Zahir. Are you present, ma'am?
Yeah, ma'am, I'm present.
Okay. So we are making a presenter. Your presenter, ma'am. Please share your screen and start presenting. Please make it full screen, ma'am.
Whether my screen is visible?
Yes, ma'am. It is visible.
Okay. Okay, thank you. Good evening,
Next 10
everybody.
minutes is yours.
I'm Nilafani. Okay, thank you. Good evening, everybody. I'm Nilafani Shah, PG scholar from the Department of Renewable Energy, Gandhigram Rural Institute, India. Here, I'm going to present my academic project, which is about recovering water from textile effluent using solar dryer by implementing renewable energy technologies. Due to rapid urbanization, environmental pollution is reaching its peak. At the meantime, human well-being and their activities are also affected by the development of industries. Nowadays, we are running towards sustainable energy or processes which are sustainable as the world is on the mere edge of environmental safety. One such major problem which every country facing was water-related issues, that too mainly for the availability of clean water. Now, in India, the government is showing more interest and spending huge amount of money for cleaning and conserving the water bodies. Here, in our country, India, textile industries contribute highly on the economic development, and on the other hand, it creates more environmental pollutions. Our focus is to convert wastewater coming out from the handloom dyeing units into the recyclable water using renewable energy technologies. And also, we are investigating the feasible ways of moisture recovery from the solar drying process. What's the problem we are facing? Fresh and clean water is a limited resource. The need for fresh and clean drinking water is increasing rapidly. It is estimated that many Indian villages are facing the problem of contaminated water. As our focus is mainly on textile industries in India, we started looking in detail about the stages of operation. Water plays a vital role in textile industries and their requirement is huge in varied processing. They include bleaching, dyeing, printing, and boiling. 38% of water is consumed in bleaching process, 16% in drying, 8% in printing, 14% in boiler, and remaining 24% for all extra activities. Textile drying is a popular environmental unfriendly industrial process because they create colored wastewater that are greatly contaminated with dyes, textile auxiliaries, and chemicals. Those wastewater can be toxic to marine organisms due to the existence of metals, chlorides, and breakdown particles of dyes. Textile industries symbolize central environmental trouble because of the high water consumption. Textile effluent is a cause of significant amount of environmental degradation and human illness. Here is how we implemented the renewable energy technologies in our project. We used solar drying unit. The solar dryer works based on the principle of the greenhouse effect. The short wavelength radiation from the sun enters into solar dryer, drying glazing, and is converted into heat. This heat is used to evaporate the wastewater from the handloom dyeing units, while the remaining dyes get deposited at the bottom surface as sediments. This dyes can be further used for handloom dyeing units. As the water is evaporated, it gets condensed in the solar dryer unit. It requires some special arrangements to collect the condensed water from the dryer unit. It is the solar dryer unit in our university where we performed all our studies for this work. Its construction is very similar to the construction of polyhouse. TGA is an analytical technique used to determine a material's thermal stability and its fraction of volatile components by monitoring the weight change that occurs as the sample is heated at a constant rate. We performed TGA of textile effluent to study its thermal behavior. The shape of the TGA curve normally depends on the environment and the degradation reaction of the effluent. It is clear from the graph, as the temperature increases, there is a gradual decrease in the weight of the sample. From the solar dryer unit alone, we cannot get fresh water as such. As the water gets evaporated, it is condensed and collected at the top of the dryer unit. As I already mentioned, it requires some special arrangements to recollect the condensed water from the dryer unit. For that purpose, a heat exchanger can be installed outside the solar dryer and is collected to an air extractor which ejected the vapor produced during the process. It's a planned future work. We have planned to extend our already existing solar dryer unit in our university with the heat exchanger at the backside of it. In that, we will be attaching air extractor, heat exchanger, condensate receptor and a refrigeration system. Then coming to the conclusion, a small industry like handloom textile and dyeing unit, the wastewater generated is less in quantity and the existing technology is not cost efficient for the treatment. It can be seen that effluent loses water steadily from 50 to 60 degrees Celsius. This temperature can be achieved in the solar dryer unit. Thus, we can see that wastewater can be recycled and the water obtained can be reused for multiple purposes, thus minimizing the usage of fossil fuels. At last, the objective of setting up heat exchanger was to condensate the vapor produced while collecting the textile water inside the solar dryer. Here on this occasion, I would like to thank my professor, Dr. V. Kribakaran, Director and Head of our department for his guidance and support towards this work. Then I would like to thank this 10th International Conference on Sustainable Waste Management towards Circular Economy for creating this virtual platform for the presenters to participate and present. Thank you.
Thank you, ma'am, for your wonderful presentations here. Please unshare your screen and mute yourself. With the permission of the chair, we will move to our next presenter, Dr. Manjusha Chakraborty. Dr. Manjusha Chakraborty. Nilofar ma'am, please unshare. Okay, ma'am. Already unshared. Dr. Manjusha Chakraborty ma'am. You're already a presenter. You can share your screen. Is there any technical issue, ma'am? Okay. With the permission of the chair, we will move to our next presenter, Dr. Khawla Abi. Are you present here, sir? Dr. Khawla Abi. Dr. Lina Harmok.
I don't see them there.
Sir, Dr. Manjusha Chakraborty has already been confirmed her presence here. So shall we wait for her, sir, for a few minutes?
Whenever we can listen her audio, probably we can go ahead with her presentation. Problem seems to be we are not getting her audio.
Yes, sir. Most probably problems in her microphone, maybe. Maybe, sir. Almost accepting this, sir. Accepting Dr. Manjusha Chakraborty, almost all presentation has been done. So,
Dr. Manjusha Chakraborty separately over her phone and find out if there is an issue.
Yeah.
Just now she has confirmed, sir, her presence.
Maybe
Just now,
if she go out and join again, probably it might get resolved.
Okay, sir. So we will wait for a few minutes for her, sir.
We will wait. Is there no other presentation?
No, sir. One presentation is there by Dr. Khawla Abi, but no response we have got from.
Yeah, we have not seen his. We are not seeing his name in there. And you said there was another name other than Manjusha.
No, sir.
Okay, sure. So that we can wait for some time.
Yes, sir.
If Manjusha can try getting out and getting in again.
Dr. Manjusha is trying to join using over phone.
Okay.
Yes, sir.
We still can't hear Manjusha, so probably if she can check the audio level.
Sir, we do have a message request. She has called and said that she is joining from phone. So she wants us to wait for 1 to 2 minutes. If we still
Okay,
can't hear from her, we'll move on, sir.
That's
2
fine.
minutes is
Yeah.
let her ready herself.
Sir, yes, sir.
No. Sir, we are trying to connect with her.
Fine. Yep.
Sir, we are still trying to connect with her. Please give us 2 more minutes, sir. She has already left the meeting. Sir, I'm asking to the chair, sir.
Go ahead.
Sir, Dr. Manjusha Chakraborty is having some audio problem. So, sir, please suggest what we need to do.
I think we should open for question answer and then wrap up, because all the other presentation have been made already, right?
Yes, sir.
So we can open for question answers.
Okay, sir.
And maybe
We will now
tomorrow
move
or
to our.
if we can
Yes,
put her
sir.
in some other later.
Hello, good
Okay,
evening.
sir.
Myself Tanya from ISWMAW. Since we have done with the presentation session, next we are moving to the question answer session. We do not have any question in the chat box, so I would request the chairs, if they do have any questions from the presenter or any presenter having any question, please address to your speaker. We can go ahead with that. So sir, no response means no questions. So
Dr.
sir, I am
Majumdar,
handing over. Yes, sir.
Dr. Majumdar, would you like to start?
Okay, so I think we can briefly comment about the presentations which have been made. What we could do is maybe for example, we'll take one by one, and maybe then I'll speak one or two sentences about the paper as to how they were, what they, how important they were, etc. And then you can add, and then we move to the second paper. So there are altogether 5 papers only, so it won't take much time, right? So I'm starting like that. Is it okay, Dr. Pandey? Hello.
I'm fine with it, sir.
Okay. So we had 5 presentations. All of them were quite interesting and very useful. And I'm very happy that young presenters and young researchers, they have tried their level best to make presentations here, which were very useful and interesting. If we start with the first presentation was from Bindumala Thakuri from Nepal. So this was about renewable energy from municipal solid waste. She gave a wide view of the situation in Nepal. I was while listening to her paper, I was just remembering about my work there, because I had been a consultant from ADB in Nepal for I think about 2 or 3 projects, and these were on solid waste management, organic waste management, and so on. So her paper was also quite interesting, and she had given a very wide view. But of course, Nepal actually, I think, requires a lot of work, and there is a lot of possibility, which I felt then and which I felt again while listening to Bindumala Thakuri's paper. Thank you very much, Bindumala, and it was a very interesting paper. Dr. Pandey, would you like to say something about her paper? Hello. Oh, I think Dr. Pandey has muted himself.
Yes, sir. I'm fine with your observations, sir.
Okay, so we now move to the next one, Somakraj Banerjee, who presented about ultrafiltration with polysulfone of wastewater. They have done with dairy water, and this is again very, a very important subject, very useful research, because of course it's in a very nascent stage. We could see the, the efforts and the results and the the trial and errors of the researcher. But I'd like to say here to conclude that this was a very useful research, and one needs to develop indigenous membrane for different pore sizes, and from that point of view, this kind of work is very important, right? So, Dr. Pandey, your observation?
So yeah, I mean, this was very interesting presentation, and also if there's a possibility of, as the presenter showed, that there's a possibility to recover water on one side, but also albumin protein. And if that can be removed and used at some stage, because anyway, I mean, providing proper nutrition in developing country to all, whether they are human beings or cattle, is always a challenge. So that would be interesting possibility coming out of this paper, sir.
Good. Then we had the third presentation from Shahid Murtaza Ali from Muscat, Oman. Again, this was a very promising paper. Utilization of agro waste for as an adsorbent for wastewater. They had actually used chicken slaughterhouse waste treatment. And again here, it's a very important one and a very promising one, because if this kind of agro waste or even solid waste as such, there is market waste basically, the peels of orange and kiwi.
Kiwis.
They have found that the carbon which they have extracted or prepared from this was used for absorption in a very potential manner. Of course, a lot more work needs to be done on this, but I would say that this is very interesting, and there is a lot of good potential for further development on this project. Dr. Pandey.
So my little caution here is that the present carbon activated carbon preparation process involves a lot of chemicals, sulfuric acid conditioning, then and more chemicals you use for producing activated carbon, more waste you have to manage in the pre-processing stage itself before, I mean, it can be used for wastewater treatment. So I mean, the cost of production at some stage will have to be always seen, because there are chances that commercially available activated carbon might be much cheaper than carbon which you produce here.
Right. No, I think you are very right. Apart from the cost, the toxicity of the particular chemicals, their disposal after the carbon is extracted, that would remain an issue which needs to be tackled. So I think yes, Syed Murtaza Ali would take care of this. Thanks. And then we come to the fourth one, which is a presentation from BITS Pilani by Dr. Rishiraj Verma. So this was about modeling steady state performance of MBBR while treating the municipal sewage. And they have used Hydromantis GPSX for the modeling. I think this is very interesting, but I feel again that a lot of more work has to be done to really make it useful for actual purpose. Dr. Pandey.
Yes, I mean, I agree with you, because one thing was not coming out very clearly is if the inference cannot be drawn out without use of model on the diffuser's choice. So, I mean, a paper has to clearly spell out what is modeling contributing here in the conclusions which are drawn.
Right. Actually, a lot of work has been done. I mean, if we set aside the modeling issue, a lot of work has been done through the mechanical aeration versus the diffused aeration. And usually the smaller facilities, they go for diffused aeration, whereas the larger ones go for mechanical aeration to make it stronger and more forceful. But here, as you said very rightly, one has to see what is the particular contribution of using the modeling route as such. So I think the researcher would look into this and work further. The fifth and the last presentation was made by Nilofer Nisa Zahir. This was about recovering water from textile effluent using solar dryer. this again is a very, very important topic, as she herself said, from the environmental issue, from the water use issue, from the energy use issue or electrical power use issue. The issue of textile effluent, this remains a very important one. And I felt this is promising, but I think a lot more needs to be done to make it actually useful. And Dr. Pandey, I think you'll have suggestions. You have also worked on textile
Yes.
wastewater. So Dr. Pandey.
Yes, basically the problems which were faced by Tirupur cluster, they also wanted to go for RO based or UF based or solar water recovery because of orders by High Court making it mandatory. But there are challenges, and what do you do with the residue which you are left with? And if you can't use it back again in dyeing process, which in all probability you can't, then what do you do with the residue? You are recovering water, but you are left with hazardous waste, and that problem also needs to be seen in totality.
Good. So overall, we had a very interesting presentation, and
Yes,
I would like
these are
to
interesting researchers. So especially the last one is still not completed research, so it will take some time before we get full data on this, and then it will be. I think it will be better to judge.
And these have huge potentials, and I was very happy to be with these young presenters, and I hope they would have a long way to go on a very interesting research path. So thank you very much, all the presenters. Now over to the
Thank you,
organizer.
Dr. Pandey, and thank you, Dr. Majumdar, for your remarks. Now I request all the delegates to open your camera to take a group photo.
Thank you, Professor Dr. Majumdar and Dr. Pandey, for your contribution as the session chair. And I was listening throughout. I mean, I have 3 microphones with me for 3 halls. I was just hopping. So in that way, it was really interesting. And at the end, your input as session chair will definitely help the speakers as well the researchers. So that is more important. And Dr. Majumdar is the first time in our session and in IconSWM. So I am really pleased that you are here. Pandeyji is an old person in IconSWM because he has been working with Icon for a long time. But I am very happy that we could get you. I mean, of course, Dr. Pandey has spoken to you also. So that's great. And thanks to all the participants for your very nice and deliberation on different research work activities. It's good to keep in touch with ICON, and we wish that in 2021 we will physically meet for the conference. That is more important. Okay, so all of you, please open your camera and have a photo, please. Over to manager. Over to hall manager.
Thank you, sir. Now it's time to wrap up second parallel session of second day of 10th ICON SWM-CE 2020. We have 2 more days with several technical and special sessions.
Hello.
Check, somebody wants to say something. Who is that?
Yeah.
Hello. Yes.
What's your name,
Hello.
please?
Manjusha Chakraborty, sir. Now I'm able actually. Hello.
I think Manjusha come now.
Yes, sir. Actually, I was unable to join, and my audio was not working for a long time. Now I'm able.
So maybe we can look for. Yeah, we can give you 10 minutes.
Okay.
Yeah, sir. Thank you so much, sir. Sir, I can share. I can present from my mobile. Actually, my laptop was not working. That's why.
Go ahead.
Okay,
go
sir.
Ahead. Go ahead.
Go ahead. Okay, sir.
I welcome
Hello.
Manjusha ma'am. After many technical difficulties, you are here. We are glad to
Yes,
accept you here.
yes, yes, ma'am.
Ma'am, you are the presenter right now. Kindly check if you can present your screen. And the next 10 minutes, this time
Yes,
is
ma'am.
yours.
I'm trying for a long time, but I'm not.
Ma'am,
Yes,
you are the
ma'am.
presenter.
Is it visible, ma'am? Is it visible, my screen?
No, ma'am, not yet.
Yeah, ma'am. Is my screen visible?
No, ma'am, not yet.
Yes, ma'am. Is my screen visible? I'm so my share screen. No, my where from I would share.
Ma'am, see, you are having a option. We got 4 options: mic, camera, screen, and leave. You have to use the screen, share screen option. You are already a presenter. So just start sharing your screen.
Is it visible, ma'am? Now?
Not yet, ma'am.
Is it visible? Yes, share.
Ma'am, kindly select the screen and then share.
Ma'am, in mobile, how to share?
Ma'am, I think you have got 3 options. Kindly select the screen and then use the share option.
Mobile, where is the share screen option? In laptop, I found share screen.
Professor Ghosh, is there a possibility to include Manjusha in some other session subsequently?
Yeah, that's good. So Manjusha, it's a good thing that we
Seems to
have
be
a
very
session.
helpful to her.
Yeah, you are right. We have a session tomorrow and on 7. So let us
Just a
check.
minute, ma'am. Just a minute.
We can see you, Manjusha.
Hello?
Yeah, we can see you, not your presentation as yet.
Hello? 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 Can you hear me?
We can hear
Hello?
you, we can see you, but we cannot see your presentation.
So, ma'am, sir, I'll open my presentation here. I have already opened it. Just a minute. Is it visible, sir? Share as options. Is it visible now? Hello?
No, ma'am. Ma'am, I would kindly request you that please, I will talk to the secretary team and we will just allot you in the next upcoming session which we are having tomorrow.
Sorry, ma'am. Start sharing. It starts sharing. Is it now shared?
No, ma'am, not yet. We cannot see the screen yet.
Ma'am, should I minimize the screen because my presentation is in another folder? When I'm opening it, I'll have to minimize the screen, no? How can I show my share?
Yes, ma'am. Yeah, you're good. Your screen is visible. Just open the PPT right now and please go ahead. We can see your screen. Just open the PPT. Yes, ma'am. You're going good. Just do the
Is it visible now?
just select the option share. There is a blue button.
Yes, there. Is it?
Hello, Dr. Pandey.
Hello?
Dr. Pandey.
Hello? Yes?
Yes, sir.
Can you hear Dr. Pandey? Yeah, what we feel as this is not the training session for display. So because we have other work, so if you kindly instruct guide that the presenter will be given time on either 4th or 7th, we will she will contact us Possibly. But
No,
however, if she can do it, it's all right. Otherwise, she should practice with our secretariat tomorrow, and we will assign her either on 7th or 4th.
I
Please
think
convey, and you can conclude. Yeah.
that is a better option, because mobile also will have limited bandwidth.
No. Yeah.
Yeah. So Manjusha, what we suggest you is that you can reschedule it either 4th or 7th in one of those slots, and talk to secretariat, and before that ensure that your laptop is working, because for large presentations mobile is not very effective tool for making presentation, and then it can be assessed in that session, your presentation. Is that all right with you? Manisha, can you hear us? Manjusha, sorry. Manjusha, can you hear us?
I think there is a problem, so let's not linger it. Let her be
Yes.
placed in next session somewhere. Dr. Ghosh should look into it and find out a solution.
Sure, sir.
Now it's time to wrap up the second parallel session of second day of 10th Icon SWM-CE 2020. We have 2 more days with several technical and special sessions. Tomorrow we will meet again at 11 a.m. with the same link for this hall. Till then, stay safe. Good night from India. Thank you.
Thank you and good luck, everyone.
Thank you, chairs and all the presenters. Thank you. A very good night.
Thank you, sir.
Welcome everyone, and thank you, Professor Ghosh.
Thank you, Dr. Ghosh.